I'm not quite as old as Richard made out to be. I started with the Milk River Watershed Council in 2011, actually. But yeah, thank you, Margot, for the invite today. You're getting a double dose of the milk. I'm going to take a little bit different perspective, in terms of talking about the story of the 2020 diversion failure on the Milk River system and kind of how it impacted the watershed and yes, particularly the irrigation producers in the area. So yeah, so I'm going to go. I'm probably going to slide a little bit faster over some of the diversion history, but the Milk River Watershed Council Canada, we've been in business basically since about 2006. Multi-stakeholder group, one of 11 watershed planning and advisory councils across the province, and we fit the needs of the community and take a lens of sound science for watershed management. Alan did a great job of introducing the watershed. We're transboundary, connected at the head and the hip with our partners in Montana, and we, even though we're one of the smallest of the major watersheds in Alberta, we're quite integral to the communities down south. Our land cover is kind of a split. There's about 80% is native grasslands, with the balance in cultivated croplands. Ownership is about 70% public lands, with the balance in deeded property. So irrigation is very important to our producers. We have a forage deficit. We can't produce enough forage in the basin naturally to accommodate the livestock production that we have on our extensive native rangelands. In the Alberta portion of the basin, we've got approximately 8,600 acres of irrigation, and really we're rounding error compared to our neighbors in Montana that are critically reliant on the diversion water from the St. Mary's system and the milk to feed the highline communities of approximately 105 to 150 thousand acres of irrigation in the Montana highline from Havre down through to Glasgow to the confluence of the Missouri River system. So in order to kind of understand the situation and what happened in 2020, you kind of have to turn the dial back quite a ways. So again, to the early days, these are some great shots from A.E. Brown from 1912, when some of the large ranches were operating in the area. There wasn't a lot of water. This is kind of a rare photo out for a poll. Besides the occasional beaver dams, there wasn't any major impoundments on the Milk River system. And really, what you see on the far end of your screen there is what we would see for natural flow of the Milk River through the whole season prior to the diversion being completed. So it really was in a lot of ways ephemeral river. Wasn't not a large significant flow, but a large meltwater valley that presents some of its own challenges. On the downstream end of the watershed in Alberta, we get into the sandbed reaches, which during natural flow periods, even within a 24-hour period, you can see the thalweg, the main part of the channel, moves from side to side the bank, and it's really dynamic. So this was a non-colorized photo was in Alan's presentation. This is my favorite part of the presentation is seeing the history of the diversion infrastructure. This was clearing trails in approximately 1910 up by Bab. This is the construction of the control tower at the Sherburne Reservoir. In the early days, it was after the completion of the actual diversion. This was about 1920, I think, when this photo was taken. And this one is a pretty cool shot too. The diversion siphons. So there's two sets of siphons coming up in Montana. You know, this is stuff that was created at the time of the Titanic. This is incredible infrastructure that was brought up on pipes that were brought up on buggies and heavy transport. But yeah, you know, this is a shot here by Bab after one of our Chinook winds blew some major pieces of pipe. Those are, help me, Alan, I think they're 8 feet in diameter. approximately. So this is some pretty heavy steel that was getting moved around. This is during some of the construction on the original siphons. And more important to the story of 2020 is this is drop structure 5 during its construction period in approximately 1916. So the diversion infrastructure that Alan mentioned has largely served both the communities in the High Line in Montana and the irrigators and the municipalities in Alberta really well for over 100 years. So 2020, I think, was 105 years since completion. And besides, this was a canal failure from that was being cleaned up in the late 70s. Besides the occasional maintenance, it served its purpose really well. Here's a shot of Sherburne Dam and the control. And then, as Alan mentioned, the diversion itself and the siphons. This is affectionately been called the Bab Car Wash, if anybody's familiar with it down there. As Alan mentioned, with the vibration and the amount of water that runs through these pipes is pretty incredible. And when it does spring a leak, you can pretty much drive a car right up to it and get a free car wash. Here's the diversion going over top of the St. Mary's. And alarms were first sounded in 2001 when there was a failure on one of the siphons that caused a 2-week disturbance in the diversion during early August. And in that year, we seen the lower end of the Milk River go completely dry through that sandbed reach for the first time. So these are some shots from drop structure 5 that's important to the story for 2020 from 2018. And as you can see, that with minimal changes, those drops look real similar to where they're done, except they're definitely showing their age. Our Nemesis plywood and 2x6s were holding together some of the retaining walls at that time, and alarms were sounded at that time that we need some significant investment in infrastructure in Montana. This is during some maintenance period when dewatering in 2014. It's really important to note that the time has come for looking at the system and looking at investment into new infrastructure. So just to kind of give a bit of a situation for the Milk River itself, when the diversion flow is coming in, on average, we're seeing approximately 600 CFS coming into the milk system. The full channel that our communities on the Milk River and Canadian side are used to seeing is looking at flows at approximately 16 to 18 cubic meters per second. And when there has been removal of that water during the season, those flows are significantly reduced. So in 2020, I got really good as the pandemic started making sourdough bread. I kicked back up my winemaking habit, and Lord and behold, May 17th, 2020, that drop structure 5 on the St. Mary's diversion at the tail end, which drops into the North Fork of the Milk, failed. This is the only time I'm going to be critical of the Alberta government, but in my presentation. But the U.S. Bureau of Reclamation and the Milk River Joint Board of Control had a notice out by Monday morning to their constituents, and AEP informed the town of Milk River of a long weekend water disruption from canal repairs the following Friday. So they didn't even fully understand the extent of the failure and what this impact could have in terms of long-term ramifications to the community. Here's another shot of that mass wasting event when the drop failed. This is on the North Fork of the Milk River, just on the Canadian side. On the following Monday, it was basically a soup. the amount of mass wasting that happened from the diversion failure was quite impressive. And that shadow of that failure stretched for probably about 20 kilometers on the Canadian side. So when crews finally were able to get on site, the assessed damage was quite significant. And at least the Milk River Joint Board of Control and our Montana counterparts, they assembled quite readily to decide immediately that a full replacement was going to be necessary on those structures. So repairs began almost immediately to the drop structure 5 and drop 2, which was near failure a little farther up on the system. Weather delays did slow some of the progress on drop 5, but crews did make up additional time. So this is, we're making sure I'm in the right spot here. This is a shot here of geographically the area. I apologize for the Google Earth images aren't the greatest, but from approximately just south of Cardston off of the 501 in the Speed Corner, the closest point where the drop structures in the canal come across is a spot called Immigrant Gap. And we're really lucky. I'm happy that our MLA, Grant Hunter, is here today. Both Grant and our MP, Glenn Motts, worked hard to get special permission for to use what they call a regular border crossing, basically a barbed wire fence along an old gravel road at Immigrant Gap. And we were able to source materials from Canada, which right now wouldn't be possible with the Buy American policies, but they were able to source both aggregate from the Del Bonita area, which was only a couple miles down the road, and concrete came from Cardston. This saved the Americans nearly $3 million US, and it shaved off a lot of repair time on their schedule and allowed for more extensive work. So this is a bit of a zoom in just below Immigrant Gap. You can see where the 5 drop structures are along the system just before it drops into the North Fork of the Milk. So this is a shot here of drop 2. This is during some of the repair work. Pardon me, I gotta make sure I'm not misleading anybody here. This is on drop 5. This is just above the North Fork of the Milk, and again, here is the same spot where we were looking at in 2018. And then I like, this is drop 1. I like to consider this like the drop structure went to the dentist and got a veneer on top, or some people have said lipstick on a pig, but I don't like using that analogy. Yeah, and in regards to the water flows, Alberta Rivers app has been fantastic, and during 2020, I'm pretty sure that majority of the usage of that app came from our producers and our managers down in our area, and it gave us an indication of what real-time conditions were like. So this was in June of 11th. We were sitting at approximately 6.45 cubic meters per second for natural flow only. Which does allow for the continued irrigation on the Milk River system, but it does provide some challenges for some producers. So with the diversion failure, we had an opportunity as the Watershed Council. This is the first time in 105 years that we'd seen that natural flow only on the Milk River through the whole system. And so we had an opportunity, a challenge, to mobilize and facilitate the collection of as much environmental data as possible at this time. Our research and monitoring team convened at the end of May with a broad range of partners. including water quality specialists, fisheries biologists, wildlife biologists, environmental scientists, range managers and researchers, and we started collecting as much data as possible. Over the coming months, we used everything from camera traps and time-lapse imagery to document changes along the river and monitored water down the whole system. So pretty lucky. This is probably one of the more complete data sets for major watersheds in the province. The Milk River Council, in cooperation with Alberta Environment and Protected Areas, has been collecting data on mainstream milk continuously since 2006, and this data was really important for us to make comparisons with the natural flow. So just some of the general observations, despite the low flow and high temperatures, we still met dissolved oxygen and pH continue to meet protection aquatic life guidelines at all sites along the river. Conductivity was a lot higher than typical years, like natural flow, which was influenced by groundwater in the area and surface from springs. Regional groundwater tends to have high dissolved salts and contribute to higher conductivity. One of the major challenges we did note was that total phosphorus did not meet any of the water quality guidelines or objectives for especially the lower reaches. In the typical diversion periods, the North Fork 501 generally meets. So generally when the water comes in from the St. Mary's system, it improves the water quality on the milk. And without that, we were seeing some of the elevated numbers were 4.7 to 11.2 times greater for especially phosphorus. Good news is there wasn't too many exceedances for total nitrogen on the natural flow, despite the low flows. But compliance with the total suspended salts was a challenge, and likely due to the low flow and no dilution factor, we did have some challenges with fecal coliform bacteria not meeting a lot of the recommendations. So that was a challenge. And some reaches we had some major filamentous algal blooms, and there was some challenges observed that was unanticipated until we seen the low flows. This was kind of a fun project, putting out some time lapse. We really wanted to kind of capture the changes in the river over the season as the bank aquifers started to decline and the river flows went down. We wanted to see what was happening, and the observation network, we had cameras at about 20 different sites along the river, and we had producers and community members that were collecting observations for us throughout the season in terms of like fish stranding, any changes that they've seen, upswelling, other stuff that was happening. And some of the interesting stuff that happened was a continuation of flow connectivity. We didn't expect this. The groundwater actually continued to keep things moving quite well. And to be honest, we had some timely rains that really helped maintain some channel flow and connectivity. Influence of the local groundwater was high, as I mentioned, and there was observations of less of the large-bodied fish strandings. There was some fish strandings, and particularly later in the season. And this is kind of interesting. Some of the trail cameras, I think I had about 20,000 photos of cows. So we worked with some of our producers on adjusting some of the grazing timing down near the river and that. But unexpected consequences on some of the camera traps. We actually found there was quite a few incidents of trespass, and especially in the lower reach. And then when you get into the bow hunting season, there was quite a few folks that were taking quads to get into some remote country that they might not have otherwise been able to access, except by foot. And then by the beginning of August, August 1st, we hit zero natural flow at the town of Milk River. So our channel was virtually dry. But interesting observation was that not a lot of people believed we were at zero natural flow, because there was some areas where there was still quite a bit of water moving, and that was a lot of the groundwater influence. So that was a really interesting observation. In terms of the fishery aspect of things, we already mentioned that some of the large-bodied fish were not showing up in some of the sampling efforts and work that was happening. And even on some of the trail cameras, we actually captured some shots of eagles coming down and picking up large fish off the river with no turbidity and not a lot of cover. But areas like this spot here on the river where there was a large root wad were really critically important, and that's actually a picture of a stone cat in the bottom corner there. It's the only river system in Alberta that has catfish, and that the fisheries work showed that the young of the year and the younger age classes did really well, and they were quite resilient to the low flow conditions. This is on the upper reaches. This is another species at risk that we have in the watershed. It doesn't like me too, Alan. So this is a sculpin in the North Fork of the Milk River, and they seem to be doing just well. They don't travel very much, and they did just fine with the lower flow conditions. So I mentioned that we got lucky. July 1st, we had almost 5 inches of rain in the Del Bonita area by Whiskey Gap, which is virtually unheard of. That was basically a miracle rain. That for our irrigation community, they were able to limp along for another couple of weeks after that, when we anticipated that they were going to hit zero natural flow sooner. And really the limiting factor for a lot of our producers was their equipment. Some of the guys that were in good locations, because they're only direct draw from the river system, they were able to continue, but others that were in shallow spots were already off. So during the monitoring work, our irrigators, generally there's a set calculation that's used as for an average consumptive use of water, and the reality was that in a season where we didn't have as much we didn't have the diversion flow in the river, our water usage was actually significantly lower because some producers just simply couldn't access at that point. I apologize about this feedback. This is terrible. I'm not too sure if it's going to be all right. So again, I mentioned there's about 8,600 acres. This really affects 40 farm families directly. This is critically important to their operations. Going into 2020, we already had a difficult year. Everybody knows that our dryland production and forages was probably about 40% of average. And coming into 2020, as a diversion failure happened, our irrigators got together with our community leaders, and we projected that our losses were going to be, with a full loss of season, $2.5 to $3 million of production in the basin, which doesn't necessarily sound like a lot when I know a lot of you folks are dealing with large irrigation districts, but when this impacts directly those 40 farms, this is life and death in some cases. I'll put it that way, especially the folks that have high input costs and specialty crop production. Water use monitoring was really important. We tried to stretch our water use as much as possible during the season. Communication, I mentioned the challenges early on. Alberta, our regulators with Alberta Environment didn't have a contact list outside of largely outdated mailing list for the irrigation members in the watershed. So we got together with our water supply management team and the irrigators in the basin, and got together a full email list and contact information so that our irrigators could be up to date as soon as possible. We had a lot of public interest. Even the New York Times did a story on the system, and that really helped us to tell our story at the time. Oops. And on October 10th, after only 22 short weeks, water was actually flowing back in and came back over drop structure 5 and into the North Fork of the Milk. And even though this is at the end of the irrigation season, this really helped nurse some of those communities through Havre with the Fresno Reservoir, get them through the winter, and then also to be able to bring Sherburne down as much as possible to safe operating procedures for the winter with the U.S. Bureau of Reclamation. Here's a finished shot of drop 2, and there's drop 5 again with the first water. So a lot of lessons were learned. It was interesting reflecting back on the flood situation in 2013, but also more importantly going all the way back to the drought situations in 2000, 2001, 2002. The Watershed Council got a grant from Alberta EcoTrust to help pay for some water shortage contingency planning work, which identified some priorities. For one, for the landowners for us to do a better job internally of telling our story on our water use and water use reporting, as well as the importance of water sharing agreements, recognizing that only a few irrigators were able to access that water during that low flow period when we got below the 4 or 5 cubic meters per second. Those agreements can be really important. The basin was basically closed to new allocations in 1986. I think one of the last junior licenses on the Milk was actually River Road Hutterite Colony, and some of the earlier licenses have the majority of the water rights on the system. So the irrigators have agreed that collectively they want to make sure that we're managing that water to the best ability and the best interest of all water users, and we don't want to get into a situation where hard decisions need to be made about individual licenses taking priorities. And so that's something that's continued work that we're going to continue to work on. There's also identifying some challenges or pinch points with regards to surface water license for a bulk filling station at the town of Milk River that really services a lot of the community members in the direct vicinity of the southern part of County of Warner. And we need to be looking at both for fire preparedness and for future water shortage situations, looking at some alternative sites where we can possibly develop some bulk water opportunities. And we really wanted to make sure we documented these challenges and what actions were taken, both from the urban municipalities to the water users to the rural municipalities, so that next time that we have this thing happen, which is going to happen eventually, that we're prepared and we have a path moving forward, so we can not make quite so many bumbles, especially in terms of communication. The water quality challenges with natural flow was really interesting, both in terms of water quality concerns with salt loading for our irrigated farmers during natural flow in the groundwater only scenario, but also for the urban municipalities. A lot of energy and resources have been put into centralizing, just like the rest of the province, some of our water licenses for municipalities, for town of Milk River, Village of Coots, Sweetgrass in Montana, as well as a number of water co-op users, and that provides some vulnerabilities, and there's still work that needs to be done to make sure we have municipal backup plans in place to address that. And the water quality treatment challenges were significant when we get into high phosphorus into our ponds system, our storage system. So. Some really cool stuff is happening with isotopic source tracking of groundwater inputs. So some samples we're taking during the natural flow period to try to determine if we can get a better idea of what those channel losses and inputs are coming from on especially the eastern reaches. And another really interesting project, which I'm sure will come on your radar here in the next couple of years when the products are completed, but there's some remote sensing work done with the U.S. Geological Survey and Environment and Protected Areas, and the Watershed Council are supporting the project, where we're looking at using remote sensing data to estimate consumptive water use. And for the first time, we'll be able to do an apples to apples comparison with the same data sets from Montana and Alberta. And I think that'll better help tell the story with Alberta in terms of what we're doing, and it might allow for better work with IJC. So, and Alan mentioned already the IJC St. Mary's Milk River study. We really do feel like this is going to be the first time where the two countries are looking for both administrative and structural changes that are going to benefit to both countries. And I feel like that's a fundamental shift from the early 2000s, when it was really looking at protecting ourselves and Montana protecting itself in terms of their allotment. There's definitely room for improved management of both the joint St. Mary's and Milk River. And our irrigators on farm, they're gun shy about making additional irrigation system improvements, because you can't pay the banker if you're not going to have water in August. It's as simple as that. So there is a generational transition that's happening right now, and some of the younger families that are taking over, they want to make the right decisions. They want to be environmentally cautious and also be using their water correctly. So hopefully this will, the outcomes of the IJC study work will hopefully come to a point where we can have some long-term water security for our existing license holders. And one thing I did want to mention, one of my board members is famous for saying we're donating 20,000 acre feet per year to Montana off of the milk from the early system freshettes and meltwater off the Milk River Ridge. And that sounds impressive on when you're talking about 20,000 acre feet. But the reality is that on the St. Mary's system, our Canadian irrigators and everybody downstream is benefiting from anywhere from 70,000 to 90,000 acre feet a year annually that would be entitled for the American water users. And we have to be conscious of those numbers when we're making management decisions on both sides. So with that, I really thank you for the invite to present today. Hopefully I didn't want to get all over the place. There is going to be an elected officials tour in the summer for the infrastructure down in Montana, and hopefully by September we might have an open public tour to go and take a look at that work there. We're working with the Milk River Joint Board of Control and our sister organization Montana on that. So I'll make sure that Margot has that information as well, and it'll be open for folks that want to kind of see some history. Thank you.
Good morning, Rossford County, Warner. Tim, could you maybe touch on I mean, we're dealing with incredibly old infrastructure down in Montana. Could you touch on the repairs and the replacement that's to happen with the diversion that's coming up, and maybe what the impacts to the Milk River users and the St. Mary users as well?
Yeah, that's a great point, Ross. So we just publicly got information last week, actually, that they have finalized the design and replacement funding and schedule now for replacing the St. Mary's diversion weir itself, which has had a lot of challenges in terms of species at risk and bull trout entrapment. It's been a black hole in terms of some of the major challenges in the upper area there. The new plan is a $90 million project, US dollars, for that full replacement. It's going to start in the spring of 2024, and I believe it's going to take till the end of 2027 to complete. But that will be, as Alan mentioned, you know, there's the idea is to restore the capacity on the canal to the full amount. So 850 CFS is kind of as a target. There's still lots of other work that need to be done in terms of upgrading on the canal itself and the replacement of the siphons that were completed in 1917 and are still fix on fail. So there's still probably $150 million US infrastructure deficit of things that still need to be replaced there to give water security for the Canadian Milk River users. But we've stepped in the right direction, and I think that both the work of the Milk River Joint Board of Control, the Bureau of Reclamation, and the broader study is going to make sure that we have security for another 100 years.
Good morning, Colin Hogan with SMRID. I have just two questions. One, who is the kind of overseeing the engineering for these rehabilitations that are going on?
Alan, you know the main engineering firms?
Just in general, like, is it? Okay, USBR is.
Yeah, and I think the Army Corps of Engineers are because the diversion, I think, was was designed, they've got a scale model of it down in Colorado right now. Bureau of Reclamation, yeah.
And my second question is, with all of the drilling that's going on with the helium in southern Alberta, do you foresee additional water requirements or asks from that effort?
There would be there would be challenges in terms of there wouldn't be a new license available. There might be some opportunities for temporary diversion licenses. A lot of our industry that already work in the area, they use minimal water use practices for some of the downhole drilling, but it hasn't really been on the radar much yet. So it wouldn't surprise me if it's something that we have to take into consideration, because we've got limited bulk water supplies that would be able to be applied for some of that, and it is pretty water intensive. So.